I'm Stephen Foskett, the organizer of Tech Field Day, and this is Storage Field Day 11 coming to you from San Francisco. We invite a group of independent bloggers, podcasters, and other IT influencers to come from around the world to discuss and learn and interact with interesting companies. This morning we're at Scality, and if you'd like to learn more about this presentation or any others, you can go to techfieldday.com. If you'd like to see some more videos from this, you can find them at youtube.com/techfieldday.
So good morning, I'm Giorgio Regni, CTO and co-founder of Scality, and we're going to talk about our new S3 connector. So we've done a redesign of our S3 interface, and we kind of looked at it from these four angles. So it has to be easy to deploy, and that's how we use Docker, and easy to deploy for a developer as well, so that he could use it for his own test without having to deploy the entire system. We wanted it to be very thought about multi-tenancy at the core, and encryption of data at rest and security. But that's because we see a lot of use cases in the enterprise where one application is not enough to justify deploying an object store. But actually, if you look at multiple applications, multiple departments, this is where you get the petabytes. So a single platform should be used by multiple users. We've worked on integration with directory services, like Microsoft Active Directory, and Vianney will do a demonstration of that. And we focused on utilization, reporting, and management, so that even internally, you can easily build users on their usage, know who's consuming what and quota. So the deployment model is, so you have the ring node, and you deploy the connector on the ring nodes themselves. And they come in 4 containers. One is the S3 server stack, so that's the protocol implementation, and that's the piece that is open source. Then you have this vault, which is kind of where we store all the ACL, so police, security, access keys go into that vault component. We have a metadata engine, which is a new database that we developed specifically for this product. And then SproxyD is our native connector to the ring. So all of this runs on the ring nodes, and they become one huge distributed S3 cluster.
And is the vault just data sitting on the ring?
Yeah, so the vault actually uses metadata for the metadata engine to store its data. And so this becomes a big petabyte-sized cluster of S3. It's fully scaled out, so you can connect to any of your S3 connector with a load balancer. And I will zoom into some of these layers. So in terms of security, I don't know if you're familiar with AWS and IAM. So that's Identity and Access Management. So we implemented the entire IAM stack with policies, groups, users. So that's basically a very fine-grained way to kind of lay out who can do what. So you have an account, kind of multiple accounts. Inside the account, you have users. Users belong to groups. And everybody can have policies, and the policies are very flexible. So you can say people can only write into this hierarchy in a bucket, and only the super admin can actually delete object. You can do a lot of file-grained policies with IAM. So we're actually compatible with the AWS tools for configuring IAM, and Vianney will demo that.
Can you extract and store them in JSON format like you can with S3?
Yes. Yeah. Of course. Can you demo that today? Or? Yeah, perfect.
Can you, going back to earlier, you were talking about, I forgot what terms you used, but having, for archive purposes and compliancy purposes, can you have it set up so that no one can delete an object?
On the policies, yes.
Yeah. Policies.
Yes. Yes,
right.
And if you were to do it with the policy verbs of S3, yes, you can design a policy that nobody can delete the content.
Okay.
And it's all REST-based for API and management. So let me talk about the different components. So IAM, see, we're using the standard AWS tools. So it's not Scality tools to manipulate IAM. And they actually format the JSON and things like that. But we are fully compatible with the IAM protocol, not just the S3 protocol. We've also implemented bucket level encryption. This is integration with existing key management system. like SafeNet, for example, where they do manage the keys of encryption. We don't store them. So we just go to the KMS to know which key to use for a particular user. So this is the demo we're going to do. So I guess, Vianney, you can come in. So to give you some context, so we have set up an Active Directory system, so Windows server. We have a S3 connector running and the entire suite of containers. And Vault is configured to be in the flow of the user authentication path. And to get a key into the object store, we have to authenticate for Active Directory first. Right? And so we're going to demo that. So the way to connect with Active Directory is to go through
Switch your microphone. Oh, yeah. Thank you.
is to go through SAMR 2.0. And so we install on the Active Directory something called ADFS, which gives you a bridge between SAMR and Active Directory.
So I'm on the machine hosting Vault, which is our authentication daemon. So as you see, we can see all the services running as a Docker container.
I don't know if you can see. Can you zoom a little bit?
Yeah. So as I said, you can see the services running as Docker containers, and especially the Vault service.
You run each service as a separate container.
Yes.
Yeah. And from here, I can type commands to see users, groups, policies. So with the standard AWS CLI. Okay, here I got two groups, as you see, called ADFS Dev and ADFS Production. And so I'm using the standard IAM tool, okay, from Amazon. And I will show, actually they have two different policies bound to them. So there is a set of commands to do that. So. I think it's let's attach group policies.
So if you're using containers for each service, each task, is that how you do your multiple nodes on a physical server? You just spin up another group of processes and they become the...
So the S3 server can be standalone and is going to use Docker volume to store the Vault data, for example. Or you can have the entire distributed system on one box, and then that's why you saw multiple metadata. When you did a Docker PS, all five of them are on the same machine, different container.
And how do you handle the networking across multiple physical nodes? Because obviously, until recently, the networking of
So the trick is we use 127.0.1.2.3.4.5.
Oh, okay.
Yeah. So here, I list the detail of every group, and you see the production group is read-only, while the development group has access to all the files.
What is it, God mode?
Yeah, God mode is basically read and write. Do you want to see something else here? We can detail the policies, but...
Can I ask a more philosophical question?
Yes?
What advantages do you get by running all of the services as containers?
That's a good one.
I just...
Maybe Giorgio can do it.
That's a different question. So, first of all, one of the first advantage, and I guess that's why Docker is popular with developers, it's really make it easy for the development process. Because anybody can have a standalone metadata system, for example, without having to download all the dependencies, without having to make sure it has the right version of Linux. And so,
Okay, so
gives
it
us a lot of
eases- it eases
predictability.
deployment.
Yeah, makes it much more predictable, especially, and when you deploy to customers, we may have Ubuntu something libraries in our container. Even if they run another version of Ubuntu, we don't have to think about all the dependency here. So that's one very good use case. The second one that we saw is development, ease of deployment. The other model, actually, what I think very useful is that we design containers to be stateless. So the metadata service can be restarted at any time. The service that is S3 can be restarted at any time. So by having them in their own container, it makes for a very good logical grouping. So I want to update only the S3 stack. I can just restart all the S3 containers without touching the metadata layer. So that's a good way to abstract it from an operation point of view.
Okay. So
Much better.
I continue the demo. So I switch to the Windows box. So it's a VM hosted on Amazon. And I can check there is a user. So through the standard Active Directory management console. Okay, launch it. So I will take the user test, for instance, which is a very standard user. And I will check the groups. As you see, the user test belongs to 4 groups. So 2 of them are standard Windows groups, I would say. And the 2 others actually are created by us. And they follow a specific naming scheme. As you see, we start with AWS dash something. And we are going actually to map them to the 2 groups here. And the trick is we are going to replace AWS by ADFS dash, just for the fun. So that's it. I'm going to the ADFS management console now. And I will check that I established what they call a relying party trust, actually, which is ADTest2 in this case, where we configure all the endpoints, especially the links between the ADFS and Vault, our service. Okay, here. So you see the IP address of the Vault box here and the login endpoint, as well as the logout endpoint. Also, what is interesting is looking at the claims. So the SAML claims, if you are familiar with the topic, where here we map, but with using a regular expression, the AWS dash star groups into ADFS dash star groups. And additionally, we map every user coming from AD to an account named account1 here on the Vault box. But except from that, the user test will be mapped to a test user on the Vault box. So I will do a login with your. Do you have Chrome somewhere?
Started. You should have your path over here.
Okay.
Yeah, I was on /dot. Sorry.
So this is the IP address of the Windows box, and we are going to log in through the very basic AD. So I prefer using an incognito window for that. For the cookies. Proceed.
This private connection is not private.
Yeah. So the thing is, so the AD maintains some state in the browser, such as cookies. So I prefer being in a new session to avoid messing up with.
So now you're signing into the Windows domain controller.
Yeah. So it's asking for the login and password of test. Do you have it somewhere? Sorry.
Yeah, Evernote.
Evernote.
That's your email.
Okay. So it's the test user here. I copy the password.
It's an easy password to remember.
Yeah. It's an acronym, clearly.
Yeah. So I proceed, and I noticed the user test belongs to 2 groups, AWS dash production and development, and I need to choose a role because the two roles doesn't blend together. So because one is read-only and the other one is read-write. So I choose production, for instance.
If he was only part of one role, there would be no choice. He would be mapped to a unique role.
So it makes you choose every time as opposed to, say, defaulting to either the highest permission or the lowest permission?
Yeah, that's because we had two groups. But typically, you only put a person in one group.
So we do that exactly the Amazon way. If you look at their way of doing it, you have to choose.
Most enterprise architectures, you're going to be a member of a million and
No, these are not the Microsoft Exchange groups. These are the actual S3 groups.
Oh.
Yeah. So you need to tag the groups. There are special groups, if you want, in the Windows AD, where you identify people. And generally, you give them one or two groups, and they can choose. So here, I authentified, and I got a temporary access key and temporary secrets key, which will expire in some time. So it will be something like in...
So the keys have been created on the fly when you did the login, and they will expire automatically. So, for example, the next day, you have to authenticate again. So if you, leave a company or something, your keys don't work anymore.
So here, I'm going to replace the admin credential that I had in my AWS CLI by the credential that I just downloaded from the authentication. So I'm copying that to a back file, and I'm editing that. So where is your... yeah.
Oh, look, it's a secret.
So,
and this is, what is this you're actually doing at this point?
So now it's configuring any S3 client so that it can test the keys are working.
It's configuring a new client.
A new client.
Okay.
okay.
I'm glad you asked that question, Curtis.
You're welcome, Mark. I'll gladly be the stupid question guy in the room any day.
It's the way
I
that
even formulate it myself.
it's the way that S3 allows you to authenticate users that
Yeah.
are not directly in S3.
That's what
You give them external temporary credentials that last for a certain length of time.
Okay, I'm done. So now I should use the service, the S3 service.
And now it's going to use it with the keys that were generated. So it's impersonating that user now.
So as you see, I use the S3 service now and not the IAM anymore.
So the authentication worked, but something else didn't work, which is kind of unexpected in
Debug it.
That's the
Yeah.
Okay.
Okay. So
Okay. So we're not going to debug it live.
now,
But so we went through the authentication step, and then maybe the VM environment has a problem. So the idea is to basically show that we go to Active Directory for all the user management. We just generate temporary keys. And so if an admin were to delete a user, then it will notify us and we will remove the key. So you have total control of the users for the existing Active Directory. You don't have to manage two different system of users. So we've also monitoring stats for being able to bill either externally or internally, so tracking usage of users. So that's the same as Amazon, how much data did they upload, download, how much quota they're actually using. And so we use REST API to actually assess that information. The fact that we implemented IAM and all these things exactly like Amazon display them is you would use AWS tools to do all of that. So when you install our S3 server for our user management, for everything you need to do, you just use AWS tools. You don't have to use Scality tools for any of that. So why did we build a new metadata service for S3 itself? It's because there's a lot of policies and data placement, a lot of ACRs that's in the S3 protocol now, and we wanted to build an engine that would be good enough for that. So you can have billions of entries in a bucket, and now you have things like lifecycle management, where the data can be migrated between one site to another site. So we designed this database to be actually very fast. So we're pushing it to 3,000 operations per second, typically on a standard deployment. And that's where all the bucket listing happen, all the vault authentication information happen. And this is doing 5 copies of all the metadata. So this runs on the storage nodes. And we're coming up, that's early, that's going to be next year. But we use this as a building block for lifecycle management over multiple sites. So being able to send data between different deployment sites. And the way that we design this database, so if you use it locally, it's going to be fully consistent. What you put is what you see. If you put something, you list it, you see it right away. On a multi-site, it's going to be eventually consistent, which follows the Amazon model. We call that CRR. Where you can have 2 buckets, the same bucket active on 2 different sites, but you don't see the change on the other site immediately. You see them over time. So we built this database so that we can support that use case in the future. And that's using the CRDT that I talked about at the beginning of the previous presentation. So as I said, this new connector is a scale out everywhere in the stack. So this is our view of the different containers, the metadata service, and the ring. So these two run on the same machine. On a small deployment, these connectors will also run on the same machine. On people who do public cloud, they want to isolate this network from the actual backend store. So this will be on a dedicated, most likely VM network, because there's no state in there. We don't use any storage at that layer. So a load balancer will balance traffic across all the S3 endpoint, all the S3 servers. Then if you need more performance here, because this is going to consume CPU, because you do encryption at that layer, you do MD5 of all the data, so this can consume some CPU. If you need more, you would just scale out this layer. And so VMs is a very good idea for this layer. Then if you want to have more capacity, you would add more storage nodes, so more ring nodes. And metadata service is scale out as well. So if you need more operations per second, you would just add another 5 metadata server nodes, for example, and so on. So it's scale out at all the layers, the actual protocol stack, the metadata, the text repository, and the storage, being the ring in the backend. And you can scale all of these layers independently.
Are you doing anything to validate your S3 support in terms of being able to say how many functions you support and how accurate they are? And
a pretty interesting question. So we do. I don't have a magic number to report right now. The biggest important piece for us is for our partners to be able to use the S3 service, and we don't have any problems there. There's some tool out there like the self-test that is going to complain about spaces.
But it's not very good.
It's not very good. I don't really care about that metric because it's kind of a fake metric. What matters is application integration. Mm-hmm. And there's a few features that we're adding on the way. So we're doing the connector this way and having separated the S3 protocol stack allows us to go much faster on the protocol support because we don't have to, we can release this independently of the other things. And being Docker containers, they are easy to kind of upgrade live in production. So we're adding more features. I think the most important thing is versioning, but we're adding at the end of the year. After that, we'll have pretty good numbers. Okay,
and will you if you look at some, say, things like versioning and what effectively tiering, will you support those as they are, or will you try and do a superset around those? So,
which
for instance, well, if you look at the tiering, you can either have standard or you can move it to infrequent access or to what's it called now?
Glacier, maybe.
Yes, Glacier as the third one. But obviously, in your scenario, you've got much more flexibility in terms of the storage and where you put things.
Absolutely.
So will you create a superset and have different tiers, or would you just literally support the pure native interface?
No, it doesn't make sense to have exactly the same names or tiers as Amazon, because our customer will use Amazon if it was good enough for them. So they actually need different type of tiers. So it's a superset.
Yeah, okay.
I'm not sure I understood that answer.
So for example, somebody may ask for full flash wing nodes.
Right.
So when we do support via lifecycle policies and tiering of Amazon, Amazon doesn't support full flash S3, for example. So we have to come up with a superset of the different tiers that Amazon supports, because we're going to add.
And you
new
can't
type of
move
tiers.
things back either, can you? Once it's gone to the lower tier, it can't be brought back.
Yeah. So when we talk to customer about the lifecycle management, they feel like Amazon is doing very little for what they need.
Nothing.
So obviously we're going to have to find a way to extend it while it's staying compatible.
Yeah.
All right, I'm going to ask another dumb container question.
You like containers?
I'm just new to containers. How's that? So one of the challenges I've heard with containers, I mean, containers are made primarily for stateless application.
Correct.
Storage is a very stateful application.
Yes.
So how do you handle the storage part from a container aspect?
So, for example, we don't use all the features of Docker because some of them don't apply to us. So, for example, Docker can virtualize your network. This will be a very bad idea in our cluster. We don't use any of these features. Right? There's a Docker Swarm to automatically manage your cluster. We do a better cluster management. So we actually pick and choose which part of Docker we're going to use. So I agree, if you were to use the network virtualization, the block device virtualization, not virtualization, but translation layer. If you were to use all the tools, it's not suited for storage. We use it more for a single way to have all the dependency checkup, slice the components so that we can easily restart a component or another, but we don't use all the features. It's not needed. So in that case, the storage nodes are not running on Docker today. They are directly running on the machine. We may change that in the future. And at this layer, we actually, what's the name of it inside Docker? We're on in privilege mode, something like that.
Privilege.
Yeah, privilege mode, so that we have direct access to all the resources of the machine.
Okay.
Does that answer your question?
I think so.